Hey everybody, in this video we're going to look at solving exponential equations in a couple different methods or a couple different ways. We're going to look at exponential functions, and then we're going to look at functions that have odd or strange looking exponents in them. So how to solve each of these. So let's start by looking at some kind of a basic idea. So if we have 5 to the x power equals 25, we're trying to find out what power x has to be to make this happen. Well, you're probably looking at that and you already know that this is going to be that x is going to be 2, right? But how is this happening? Kind of what's happening with this? Well, in your mind, what you may not be realizing that you're kind of doing is you're thinking that 5x is equal to 5 squared because 25 is 5 squared. So if you have the same bases, if 5 to the x power is equal 5 to the squared, to the second power, then these two things, the x has to equal 2. Right? So we're going to use this whole same idea with a bunch of different types of scenarios and using our laws of exponents to kind of find some to solve for x when x is in the exponent. Okay, so if you're not really comfortable with your exponential rules, you're going to want to go back and review those videos first. But let's start with 2 to the x equals 16. So this is very similar to the other one. You might think 16, well that's 4 squared, but we need to get to the same base. We need to look at base 2 for both of these. So the base, or with 16, if we're looking to try and make it base 2, then we have to think, well, that's going to be 2 to what power? Well, 2 to the 4th power is going to get us 16. So 2x equals 2 to the 4th power, therefore x has to equal 4. Right? That's almost identical to the first example that we did. So let's expand on this a little bit. So now we've got 3 to the x plus 2 power equals 1 over 27. Well, we still want to look at getting the same base, the base 3. So we have to think, how does 1 over 27, how does that look when it's a base 3? Well, that's going to be the same as 1 over 3 cubed, because 3 times 3 is 9, times 3 is 27. But we still need the same base. 1/3 is not the same base as 3. So we need to change this little bit here to make it so it's still base 3. And we have to use that idea of negative exponents. So we're going to bring it up to the numerator and say negative 3 power. So now we've got the same bases of 3, and we've got x plus 2 equaling negative 3, so we can drop the bases and we can just solve our for x, and we get x equaling negative 5. Alright, so let's look at another. 4 to the x equals 8. Alright, so we probably naturally think, well, 8 divided by 2 is 4, but that's still giving us this weird 2 in there, and it's not really a base power. So how can we change this one to get so we have a common base with 8? Well, if we look at 4, right, that's not matching up with 8, like we said. So we can get to 2, and 4 is the same as 2 squared. So if we think of it that way, then we've got 2 cubed on the right side. So we can rewrite this as 2 squared to the x power, and that equals 2 cubed. Now we know with our law of exponents we can just multiply these. If we have a power of a power, we have 2 to the 2x power equaling 2 cubed. So now we can drop our bases and we can start looking at what x equals again. So we get x equals 3 over 2. Alright, just a couple more examples. 9 to the x minus 2 equals 1/3. So this is kind of combining the red and the green example all in one. So we want to get this thing into a base 3, and we want to get this into a base 3. So we've got 3 squared on the left side, and that goes to the x minus 2 power. And on the right side, it's 3 to the first power, but it's in the denominator, so we want to move that up using our negative exponents. And we get 3 to the 3 to the negative 1 power. Alright, so now we distribute that 2, so we got power of a power. So 3 to the 2x minus 4 equals 3 to the negative 1. Drop our bases, 2x minus 4 equals negative 1. Add our 4 to both sides and divide by 2, and we get another result of x equaling 3 over 2. Okay, so now so hopefully that gives you an idea of how these work when you're trying to solve with a variable in the exponent. Okay, and if you don't have the same bases, we'll look at some of those options when we get into logarithm. But that's kind of the basic way that you can solve these if you have common bases, or if you can get to common bases between your two sides of the equation. So what happens if we have another equation where we've got a very strange or a more complicated exponent? So now it's still, our base is x, but we've got this negative 3/5 power. So first thing we want to do is we want to get the x by itself as much as we can. So we're going to divide by 3 on both sides and just get rid of that and have x to the negative 3/5 power equaling 8. Alright, so now when we look at this, we probably think, what is it that's causing us a lot of problems with this? Well, that's going to be this negative 3/5 power, because how do we unwrap that from our x, right? So what we want to do is we want to take this to the negative 5/3 power, and we're going to actually do that on both sides. And why did I choose negative 5/3 power? Well, because these things are going to cancel out. So it's the reciprocal, so if we multiply by the reciprocal, we get a power of 1. So now we get x equaling 8 to the negative 5/3 power. So where do we go from here? Well, we might naturally think, all right, let's take this and x equals 1 over, we've got 5 in the numerator, 3 in the denominator, so that's the cubed root of 8 to the 5th power. But that doesn't really help us simplify this any further. That's not simple. It's not simplified. So let's take a look at this and see if we can find another way that we can rewrite this 8. So if we look at the base of it, we can say, well, that's base 2, right? So base 2, or 2 to the 3rd power, is 8. Right? So I'm just looking at the 8. I'm not looking at the negative 5/3 yet. 8 is 2 to the 3rd power. And that thing is then taken to the negative 5/3 power. Alright, so now we've got a power of a power. So we can do a little side work here. If we've got 3 over 1, that's our 2 to the 3rd, times negative 5 over 3. So power of a power, we multiply, so we can start simplifying. And now we've got to the negative 5th power, so x equals 2 to the negative 5th power. So that drops into our denominator, and if we multiply out our 2 to the 5th power, that's 1 over 32. So we end up getting our result of 1 over 32 for this. So that's a way that you can kind of take it all the way, the most simplified way, even without a calculator, even if you don't have that result or have that tool available to you. You can still use those properties of exponents to rearrange your exponents and get them to simplify and break down a little bit further. So hopefully this helps kind of explain some different ways that you can use or solve exponential equations, even if you don't have a calculator, even if you don't know logarithms just yet. So that's it for this video, and I'll talk to you soon.